This is section 5.6, last section of the course, and we're going to just cover area between curves. So if we have something where we have two separate curves, this is like x cubed plus 2x, and this is x squared minus 5. The area between them we can find with an integral. And it would be the integral from a to b, whatever that is, and then the one that is on top. So this one's on top, that's the larger, x cubed plus 2x minus the one on bottom. And always want to put that in parentheses so that you remember that those signs are changing when you're evaluating. So that's really what we're going to do in this section. I think we have 5 or 6 questions to do. Some of them are very lengthy and just a little bit tedious, but let's go check them out. All right, so number 1, you are given this picture and it says the total area of the shaded region is. Type an exact answer. So they don't want fractions, they don't want decimals, and they want pi in your answer. So we can tell this picture, this graph is going from here to here. So from 0 to pi. So those are our limits of integration. The thing that's on top is y equals 6. So we have 6 minus 6 cosine squared x dx. So the strategy for this one has quite a few little strategies in it. It's trig. Is to factor out the 6 so that you have 6 times 1 minus cosine squared x dx. And then we can pull this 6 through the integral, so he's out here. And then we should recognize from trig that 1 minus cosine squared x is sine squared x. It's going to make it a little easier for us. All right. Then we have to use a trig identity. You might not remember it. You might have had to go look it up, but I'm giving it to you right here. And there's one for cosine squared x as well. Sine squared x can be written as 1 minus cosine 2x over 2. So if we switch this out and put this in, we've got that there. I'm going to rewrite that as two separate fractions. 1/2 minus 1/2 cosine 2x. And we would do the cosine 2x by u substitution. If you need to review that, to go back to the last section and do that. But you would end up with this 1/2 and another 1/2 when you did the du and had to get rid of this 2. And so you end up with a 1/4 here. So you have, when you're evaluating, you have the 6 on the outside, and then 1/2, if you integrate that, you get 1/2 x. When you integrate this, you get sine 2x over 4, because we had this 1/2, and we have another half with this when we integrate it and do our u substitution. So then you're going to evaluate that at 0 to pi. So we'll leave the 6 out here. If you place pi here, that's pi over 2. Sine of 2 times pi, 2 pi, sine of 2 pi is 0. So that's a minus 0. If you plug in 0 here, you get 0. And here, sine of 0 is also 0. So all we end up with is 6 times pi over 2, which is 3 pi. That is our answer. So you may have to look through that one a little bit. Number 2. Number 2 is one that I think works well, that we can use our grapher. We can't do it on all of them, but on some of them I wanted to show you the technique to do that. We've got this blue area, and you want to write the integrals out. Even if you get to use your grapher, you need to write the integrals. So this one is from -3 to 0, and then this one is from 0 to 3. You can see those points on the outside. And what's on top is the same for both of them, so it doesn't change. but the limits of integration changed. So here's our integrals. Well, I'm going to bring my calculator over here and get out of the grapher and clear that. So if you hit math and you choose number 9, that is an integration kind of app that's going to let you do that. And you're going to put it in just like this. So if we put -3 here, hit your right tab there, and that's 0. And then tab over to this box. This is when where we would put all of this. So 2x squared minus, in parentheses, x to the 4th. Make that come down, minus 7x squared, close parentheses, and then go out of the whole thing and put an x there. So we filled in this box, our whole function thing goes there, and an x goes here. We hit enter. If you do that for this one as well, you get 32.4. Add those two areas, you get 64.8. And if we go out here and go to 64.8 and math and fraction and enter, we get 324/5. That is the answer that they do want. And that's one that converts okay. On several of the others, they don't convert well from decimals, so we're really going to have to work those out. But this one does. I wanted you to see that process. All right, this one's a little different. If we notice that these are x equals curves, x equals y squared and y cubed, and so they're going on either side of the y-axis. We can form them the same way, except our limits of integration are from 0 up here to 1. So 0 to 1. And so in this part of the, I don't know why I wrote 0 to 2. That's crazy. I'll have to fix that. In this part of the question, they give you the lower limit, you put a 1 here. In this box, you are putting the 6y squared, because the larger one, it's not about what's on top, the larger is the one on the right. So this one, subtract this one. And so I just need to fix that right now. All right, so it may have printed wrong. So we may have to check that one if you print the lecture notes, but I have fixed it for the video, so sorry. So you just combine all of this, and I got those in order. So that's 4y squared minus 6y cubed plus 2y dy. And when you integrate that, it's 4y cubed over 3 minus 6y fourth over 4 plus 2y squared over 2. I did cancel out the 2's, and I changed that to 3/2. Then I plugged in the 1 for y. It was really pretty easy. You had 4/3 minus 3/2 plus 1, and we end up with 5/6. So that one's not too bad. Number 4, you can also use, you should be able to use the Math 9, and we had to pick the correct one. So we're looking here, and we know this goes from -3 to 0 and 0 to 3. So we're looking for something that has -3 on the first integral and then a second one. So we had a -3 here, but there's not a second integral. This is the choice we make. And on this piece from -3 to 0, this cubic thing is on top. So it goes first minus the parabola curve. We've got that. And then on this piece from 0 to 3, the parabola part is on top, subtract the cubic part. So that's what they're asking you to do there. And then the final part here, they do want the area. You can use Math 9. I checked this kind, and it does give you decimals, and they actually add up to a whole number. So you're okay there. Number 5 does as well. Same idea. Here's from -2 to 0 and from 0 to 2, and they do change. On this one, it is the cubic on top. On this piece, it is the quadratic on top. And so you have to be sure and do that. They end up being the same, 12 and 12, and add up to 24. Now, this last one was a lot of work, so that's why I'm okay with you doing the Math 9, because I tried the Math 9, it does not work on this one. You can get it to work on your calculator. I have the newest 84, the 84, but it just would not seem to work. So I've done all the work to show you what you're doing. You have 3 pieces here. There's one in the middle, there's a little one, and there's a little one. And you can see that this one is from -10 to -9. You have to fill in the upper limit. And it is this thing, the line is on top here. And I've done that work here. So the line, -x plus 10 minus the quadratic. Clean that up, and this is what you want to use to put in here for the integrand. Then you go to this piece, which is from -9 all the way to 10. And for that one, the parabola's on top, minus the line. Clean that up, that goes there. This little piece down here is from 10 to 11. And it has the line on top and the parabola on the bottom. Clean it up, you've got it here. So you have this same integrand, just different limits of integration. But there's a lot of fractions, and I'm not going to go over every little piece, but when you integrate, just be careful, you do that, and you're evaluating from -10 to -9, and I would do it like this, and this, and then you can do this piece and convert to fractions. I just had to change to common denominators to get this middle one. This one ended up being the same here, but I did all this just little work and came up with this, and you get 69. Oh, this is wrong. This is wrong. I have to fix this too. Okay, I have corrected that. I had fixed it here because I had a sign wrong and had the wrong number. And I knew something was wrong, and I did correct it, and I corrected it there, and I had the right answer here, but I had not corrected right here. So now that is right. I will go back and try to correct the printed version as well. But that should get you through just doing the area. Several of these you can use Math 9. The trig one you need to work out, and the last one you need to work out. And that's just number 6. So I think that'll get you, and you are done with your work. Just finish that up.